Hello, welcome to MySQL QA episode number 5. My name is Roel and I work for Percona. In this episode, we'll be having some fun. We'll be setting up pquery for the first time, running it, creating some bugs. And let's go and have a look what that looks like. But before we do that, just want to give you a quick reminder, you might want to check out the previous episodes. So the first episode was all about Bash and GNU scripting. 3.5 hours of scripting fun. If you've never done much scripting, I would recommend going and having a look at that. The second episode was all about building MySQL Server, percona Server, MariaDB Server, and that would be very interesting if you haven't got your server ready yet. Of course, you can just download a binary distribution from somewhere and run pquery against that, but building allows you to use the latest tree produced by the developers. So if you haven't done that yet, you can go and have a look at that. The third episode was all about GDB, 1.5 hours of debugging fun. You don't strictly need that for this episode, but if you've never played with GDB, go and have a look at that. And then the fourth episode was a bit of an introduction to this episode and the next one, and in there you get a little bit of an idea what pquery is and does and how we've built it. So I highly recommend that if you haven't seen that episode number 4, you can go and have a look at that first and then jump back into this one. Okay, so today we'll look at mtr2SQL and pquery-run. Let's get started. So first, let's go and have a look at a live run which has been going on at my system. At the moment I'm testing a particular feature branch by a colleague and just seeing if we see any issues. The good thing is so far we're not seeing any issues specifically to the code that he's introducing, so that makes me and him probably happy. However, we are seeing a good number of crashes as we go along. So in this particular run, we're up to trial 387. Each trial only lasts 25 seconds. So, you know, if you think that MySQL Server takes hours and hours to crash, that's not true, because we've already produced 172 crashes within 387 trials. So actually, there's a crash happening just here as we speak. This is the crash message, and here you see another one that happened just before. You can see a core dump happening. So 25 seconds. See here, about 20 seconds into the run, there was some sort of issue that was triggered, and we had executed about 19,000 queries. Only 12% of that was successful, so sometimes it's 17%, sometimes it's 20-25%. But it was enough to trigger a particular crash. Okay, so in the meantime, it's running. Here's a particular trial where there was no issue, so it's not saving this trial because we've set the options to not save it. And you can also see the trials that have produced an issue. So let's have a look what this particular trial here is doing. Trial 389. There was no failure in that one. Trial 309. Let's just wait for a few seconds and see what is happening in this particular trial. And we can get an idea just in a few seconds from now. So again, 25-second runtime. Okay, so again a timeout is reached. So I'm fairly used to seeing at least one crash in every 2 to 3 issues, confirmed here by the 173 versus the 391. And here in this particular case we have another issue. So this is quite interesting to see. Notice here that it said the timeout was reached. Here it doesn't say that the timeout was reached, and here it executed a large number of queries versus here it executed a small number of queries. What probably happened here is pquery has a built-in feature that if 250 consecutive queries failed in a row, then pquery will automatically exit, and the reason could be that, and it seems clear that in this case there's no crash. The reason could be, for instance, that the user privileges were dropped or the user was revoked some privileges, or the user was dropped altogether, and a flush was executed, and so there was no point in continuing with pquery because it simply couldn't log in, authenticate to the server. So in that way, we have an idea as to what happened here. It doesn't really need further analysis because it's just simply a trial that was stopped short by some other issue. Okay, so in this case, we have another particular crash that happened here, and you can see a different assertion message again. And here you can see MySQL D being terminated and core being dumped. Here we have yet another one that is happening, and this time it's yet another assertion message. So it gives you a good idea, right? About 400 to 200. So 1 and 2, 1 and 2.5 trials crashes when we run with 25 seconds. And of course we can increase this. This is also a single thread run, so that means there's only a single client executing against MySQL D. We could increase that to several threads, but as you can see, it's not necessarily for producing a high amount of crashes within MySQL D. Okay, so let's just jump out of this particular run and let's set up a run of our own. So we've already created, and by the way, just as a memory, if you want to get percona-qa QA, simply go percona visit our branch launchpad percona-qa QA, and you want to do that in your home directory, just so it's easy to later on reference it. And you also want to branch in for reducer.sh. So there's a tool in here that's called mtr.2sql, but you don't strictly need to use this if you're just starting out. There's already a number of SQL files included with pquery. Some of these that you can see here, they're actually not within the Launchpad tree, simply because I've been playing around with various tests and been combining or subtracting from various files. So the main one that you're interested in is main ms psmd and main merged. And as you may remember, the main ms psmd, this file is a combined file of all the MTR test cases in a single line format for MySQL, Percona Server, and MariaDB. And the main merged .SQL was the previous version of MTR to SQL version 1 and 2, and I'll show you in a second what that means. So this was the old file, this is the new file. We don't really use this one anymore. You can simply use this one. It's a very comprehensive SQL grammar. So let's have a look at this file, what it looks like. And you can see here literally thousands upon thousands of lines of SQL, all self-contained, right? Each line is self-contained. There is no multiple line code. If there was multiple line code, it wouldn't work, because pquery randomly grabs a line and executes that particular line against MySQL D. So if we jump all the way to the end, there's nearly 500,000 lines of high quality SQL, and all this has been extracted from all the MTR test cases that developers have created over time. So this has given us a very high quality grammar, and that's why we're able to find pretty much every bug out there, or most bugs out there. Okay, so why would I like to still show you MTR to SQL? Well, first of all, for making this a comprehensive course into QA, and secondly, because when a new version is released, then the developers will have added test cases, they might have expanded some test cases, and so it's interesting to run this tool and possibly make your own grammars or contribute to the main grammar, etc. So let's have a look at this tool. Basically, all you have to do is point it to the MySQL test directory within a certain release. So you can see I've been playing around here with the 5.7 release candidate from upstream, and pointing it at the MySQL test directory. Now, of course, we've recently swapped to Git, so the bazaar is not necessarily correct anymore. All you have to remember is get that source tree wherever you get it from and point it to the MySQL test directory. Just coming down here, you can see that you can specify a 1 or a 2 as the option behind MTR2SQL, and basically what it does is I've written over time 2 different versions of this tool, version 1 or version 2, and they extract the information from test cases in a slightly different fashion. So you can see here the version 1 looks for particular keywords at the start of a line, versus version 2 grabs nearly everything and then filters out stuff. So version 2 is a little bit more complex, but not necessarily better than version 1. The power of the SQL file that I was just showing you before, if I remember correctly, I run both version 1 and version 2 against each of those 2 distributions and then merge the file together. So you can see how comprehensive that file eventually has become. So it's a 42 meg file that we generally use. Now you can do all sorts of things with this file, like SQL interleaving, and SQL interleaving in part is what I think the future of MySQL D might hold. You can very comprehensively test a feature by SQL interleaving. No longer the need to make custom grammars, etc., etc., etc. It's very easy to test a feature quickly and with quite a reliable and high level of quality. So, but we'll go into that in a later episode, especially the last episode. I recommend when it comes out that you have a look at that. It's a little bit of a vision for what the QA of MySQL D could look like in the future, and not necessarily the future, because within Percona we're already doing things like that at the moment. Okay, so once you've got your SQL file, and again, you don't strictly need to use MTR2SQL, but you now know of its existence, so that when a new version comes out, you can have a play with it, or when, for instance, you want to grab some MTR test cases from an internal tree or from another vendor that we haven't included yet, you can go ahead and do so. So once we have this SQL file, we can start having a look at pquery-run. Okay, so pquery-run is a wrapper script around the pquery binary. So the pquery binary is written in C++ and the source code is included. Here's the source code. It's been written by my colleague Alex Ibico, and I've expanded it a bit, but he's done the bulk of the programming within this tool. It's a very short program. It's just under 300 lines, but it is extremely powerful. It runs thousands of queries in a very short amount of time. It randomly grabs. It still does full logging. It checks for failures. Here's the 250 maximum consecutive failures that I was saying. It's written in C++ 11. Very, very powerful tool, even if it's just such a short amount of code. Sometimes code can be quite beautiful. Somebody said to me at some point, and I think this pquery C++ file is beautiful. Okay, so that's pquery. Now, pquery-run is the wrapper that I wrote around pquery binary, and basically it does all the stuff that's required. So for instance, it starts up the MySQL Server, so you don't have to use any special tools for that. It's all done by the script. It also handles percona cluster testing. You can see here the pxe cluster tools. It sets all the right options. It saves files for later reference. It cleans up. It makes sure that you don't run out of space, etc., etc., etc. Now, one thing which already became clear in RPG times, which might not have been necessarily been used by everybody, is that it's really great to use memory, def, shm, tmpfs, to run your testing. Of course, and you can see I've slightly increased it in my Avast tab here, and you can do this by simply saying tmpfs and set it to 16 gig. If you have the memory to support that. So even though in this particular box I've only got 16 gig of memory, it seems to be fine. I mean, of course, it will still do a little bit of disk swapping, but that's fine. The main point is you want really fast storage to run your main testing, so that preferably in memory, although it has a few limitations as to what you can do. I believe like ODirect is not fully supported. So there's a few limitations, but the general idea is you want to run your testing in memory so that it's very fast, and then when you have a particular crash or whatever, then you want to save it to slower storage. And if you didn't have a crash, then you simply want to delete it. So you can see some testing going on here in various directories. So pquery does all this. It simply pquery-run. It simply uses the fshm, and like I said, if it crashes, it will save a result file. If it doesn't crash, it will simply delete it and run the next test. And that way, you don't easily run out of space on the fshm, even if you have a smaller size tmpfs. Okay, so let's have a look in the script. Okay, so there are a number of things that are there already, and they need to be at the top. So sorry, but we couldn't put them any lower. These two you simply do not change. They are internal variables. PXE and Docker, let's leave those alone for the moment. There's a later episode on PXE and Docker, so we're going to skip that. There's a little function that's needed before the variables, so again, please leave that alone. And then here we have actually the user configurable variables. So pquery binary, normally that should all function automatically because it's pointing to the script directory, which is percona-qa, and it's looking at the pquery subdirectory, and it's looking for the pquery binary, which is fine. And remember to change that to pquery-ms for ms runs, or you can also say pquery-md or pquery-ps. Then you want to point it at some particular in file. So of course, you know, if you specify it twice, the second in file will be used. So in this case, we're going to be using that main mspsmd file that I was mentioning, or you can also use the main merged, the slightly older SQL file. Then you want to point it at some sort of base there. So let me leave it at MySQL 577 for the moment. By the way, you can use another pquery, like in this case I'm going to use pquery with the included percona library for testing against MySQL Server. That's fine. Interestingly, you will see different crashes, and not necessarily client crashes. In fact, most of them are MySQL D crashes, if not all of them, when using different binaries. The reasoning behind that might be that the client talks slightly different to the server, and the server reacts in a different way. That's one possible explanation. The other one is that maybe some timeouts are more easily or less easily hit, etc. So to really have extra fun, you can play around with using different pquery binaries, which are basically exactly the same pquery code, but linked together with different static libraries from each of the three distributions, and thereby generate even more crashes. So you don't necessarily have to go that far though for standard QA. So with standard QA, what we're trying to do is we're trying to set up a pquery run to get an idea of what sort of bugs are out there. And I can tell you, if there is a bug out there that the developer really did something quite wrong and this is a showstopper bug, it's going to be all over your screen. You're going to get this crash. You're going to hit it every 2 or 3 seconds, because it's very easy when you run as comprehensive an SQL grammar as we are, to see, even in a very short amount of time, what your main showstopper bugs are. And so it's quite easy as an experienced QA engineer to start this up and see within a matter of half an hour to an hour whether the developer has made a big boo-boo and this release needs to be held back or not. Okay, so that's a little bit about how we're going to do the testing, and also a little bit about the setup of pquery-run. Let's go a little bit further. So here we are setting the LD library to a particular client library. However, this is no longer fully required. It still looks for it, but the reason why it's no longer required is because pquery now has included static libraries. I suppose that we simply haven't updated this because it doesn't error out for us. So if you see little things like that and it does cause you problems, just feel free to disable these few lines. Just remark them out and simply go ahead and run it without the library and point pquery to one that includes the client libraries. So the reason why all this happened was, if you don't know about client libraries, the way this works is, so originally you had pquery, and then you would have the client library for a particular version that was included with the distribution, the MySQL distribution. However, now we have created for upstream MySQL, for percona Server, and for MariaDB, we've included pquery binaries which have statically included libraries with it, so it's part of the binary, and the great benefit of that is you don't really need to point it to a client library path anymore. It doesn't need to find the client library because it's already included. Okay, so that's fairly straightforward. So let me just leave it like this for the moment and not do too much hacking in the script, and come back here. Okay, so you definitely want to update your working directory. So I usually have some sort of hard drive that I name SDA and then SDB and SDC, simply because it's easy to access. You want to leave that random D here, and I don't know if you remember here at the top this was being generated. So it's just a random number generated that creates a 6-digit random number, and that's where it will store its files. And then you also have a run there, which, as I said, was on TMPFS, and it uses the same number there. Okay, so for percona Server it preloads JMalloc, so you can edit that if that doesn't suit you. You can simply remark it, and of course you might want to edit these options here. So you have MyExtra and MySafe. MySafe, I thank Shane Bester for his help with this. He gave us a list of options to set that would make more sense from a QA perspective, so that you don't run into some sort of issues 5 minutes into your run that could have been prevented from the outset. Basically, fail-safe settings that are set at the beginning of each run. You can also set MyExtra, and MyExtra specifically for MySQL D options. You can see a few different options here: InnoDB file per table and bin logging, etc., etc. So you can add that here. The number of trials, you probably just want to leave that to 100,000. It doesn't really matter too much, because after a few thousand trials you simply want to exit out of it and do an analysis. You can set it to 1 for valgrind run, and you can see the valgrind command here that we use. Now all of that is, of course, interesting if you want to do Valgrind runs. For the moment, we won't be looking into that. Now, the next two options are quite interesting too. So, save trials with core Valgrind only. So this saves trials only if only if they generated a core file or only if they generated a Valgrind issue. So we usually have this to 1, but if you set it to 0, it will save all trials, which might be interesting if you have, for instance, you're seeing errors and you don't understand exactly what's happening. Setting this to 0 will save everything, so it allows you to go and do a bit more of analysis. Okay, and then we have save SQL. So if you turn this on, then the trials will still not be saved. However, the SQL from those trials will be saved. And this might be handy if you get a full server lookup and you want to start debugging that. If you have save SQL set to 1, then you can go and get that SQL and try and reduce it either manually or by using reducer. But reducing a server lookup is more complex and requires you to hack reducer. Anyway, it's there if you want to do a bit more advanced work. So all of this is you can just leave as default for a standard run. This is standard, you just leave this. It's just a bit of a timeout for allowing MySQL D to start up. Now, let me just skip ahead. Okay, so do you want to archive a copy of the SQL input file? I highly recommend that you do this. And that just sits in the root of the work directory. This is for pxc, we'll look at that later. Now, multi-threaded run. You can turn this option on. However, I would suggest not doing so. There are slightly different ways of doing that. If you turn this on, it's a bit of a shortcut for what comes below, and you can see that here, multi-threaded run equals, it presets a few settings. Now, something to understand here is the multi-threaded test case lines. So if you set this to 1, then the second block will apply. So this is the second block, and if you set it to 0, then the first block will apply. So in the first block, if it's not pquery-run, then the timeout will be 15 seconds and the queries per thread, so that's even less, right? Because I was doing a 25-second run there, and you can set that here. You could even do a few minutes run, but it's just going to produce a few less crashes because it will have to run longer per individual trial, and it will run up to 100,000 queries per thread. Again, if you set this higher, you want to increase this number because pquery can very quickly, like it could rack up, for instance, 90,000 queries in 25 seconds. So you want to set this higher. Threads is 1, and multi-threaded test case lines is not used in this case. However, if you set it to multi-threaded, then for instance it sets it as default 30 threads, 130 seconds runtime, 100,000 queries per thread. However, here you can see that it will grab 20,000 lines per thread. So the way to understand that is, sorry, not per thread, per run. So the way to understand that is it will grab that original file. Remember that it had 500,000 lines of SQL. It will grab 20,000 from that randomly, and it will then execute the test case against those 20,000 lines. Now, the reason why that is done is because if you're going to be reducing multi-threaded test cases, and yes, we have true multi-threaded test case reduction, which is probably a world first. If you're going to be reducing multi-threaded test cases, if you have to reduce, like for instance, 100,000 line SQL test case, that's going to take a long time because you need to randomly hit the same bug, and we'll talk a lot more about that later. But so you want to keep this number small, not too small so it doesn't produce any bugs, but as small as possible, but yeah, still reasonable so that it does produce a good amount of bugs. So 20,000 is a reasonable number to get started with when you run 30 threads. Now in the beginning I said I recommend that you don't do this. For the moment, just get started on single threaded runs because there's already so many bugs out there just in single threaded runs, and multi-threaded runs actually do not produce a huge amount of extra bugs. It's very interesting because you would expect that if you have 30 different clients hitting the server all at once, that you would more easily run into, for instance, locking issues or anything else. That's not the case. From my experience, 85% to 95%, probably much closer to 95% of all bugs are threaded reproducible. Maybe I would even say 98%. A very, very high amount of bugs are single threaded reproducible. So for the moment, maybe just leave it to 0 and just do a single threaded run and see what sort of bugs that gives you. Okay, so let's just scroll down a little bit here and see what happens from there. Okay, so the rest of the script goes on and it simply starts declaring all the various functions that it needs, and then it runs through the actual pquery testing with all of the possible outcomes, and it handles all of those. Okay, so once you've set those options, remember that the main options are your binary, your SQL input file, your base directory, and then if you like, you can go a little bit lower and set by extra, and that's probably all you have to do to get started. All of the other options should be great by default. Okay, so let me just execute this and see what happens. Okay, so we're getting an interesting error here, so it will be interesting to have a look. So in this case we're using, and there's exactly the issue that I know why it's failed. It's simply because we're using 5.7 and we still need to make a few further updates for 5.7. So I'm just going to quickly swap that to 5.6. .7 has quite a different way of initializing a data directory than 5.6 has. Okay, so let me start that. And you can see here it was trying to use MySQL install DB, and that was probably where it was failing. Okay, so it shows you the work directory, your run directory, your base there, your startup timeout, your client threads, which is 1 queries per thread, the number of trials, that's pretty much unlimited as far as we're concerned. The pquery timeout, the SQL file that it's using, the binary that it's using, MySafe, and some more general information as to what it's doing. And then it's simply starting to run those trials as we've seen before. Okay, so I'm just going to wait for a second here until we get an actual crash, and then we can have a look into the directory. Okay, so here we have a particular crash in trial number 3. We can see that that something went wrong. So let me just Ctrl-C out of this, and notice now that when you press Ctrl-C, it actually does a cleanup for you, which is great. And at the same time, you can go and have a look. Let's do 6.6. Okay, so we had the particular trial number that failed, and we have a bunch of files. This one might have failed just because we were at the end of it. Okay, so here we have a core dump. Okay, so when you interrupt pquery-run when it's running, the particular trial that it was busy with, it will still save, but in this case we can simply delete it because it hasn't actually crashed. Okay, so that's the particular trial that we saw an error on. That's the input file. Remember that it saves a copy. There's a data template that it's generated just the first time, and then later on it will just simply use the data template to create the data directory within the trial. A log directory, and there you can see the MySQL install DB outcome. The pquery binary that was used, and if you watch carefully, you remember that each pquery binary is different, and that a different pquery binary might produce different crashes simply because it has different included client libraries and it might work slightly different. So it archives the copy with the run. It also copies your MySQL D binary right there, together with all the client libraries it needs, and for that it simply uses a script that's called LDD files, which runs an LDD on MySQL D and copies all the libraries. It also copies your pquery-run, and it just slightly renames that just so that it doesn't run into problems later on with some other scripts. But basically, this pquery-run is a copy of the one that we started, which is kind of handy because you can go back and research whatever it was that was set, like MySQL D options or whatever. Even though all of that is completely automated, it's still handy to have. And a pquery-run .log file, which contains the full output of our pquery run. So you can see everything that you would possibly need is there in multitude. And you could be as simple as going into here, going to the data directory, referencing the MySQL D, referencing the core, and okay, there we have our particular in this case UTF-16 issue and the backtrace for that issue, and we can start debugging straight away. However, most of all this is further automated, and that's what we will see in the next episode. There's a lot more tools that are written around all this, and filtering, reduction of test cases, and so on and so on. It's all fully automatic. Okay, so just to recap. So we have the pquery framework. Within that we have of course the pquery binary, and if you remember, there are three flavors. There's Percona Server, there's MySQL Server, and MariaDB. Each of those binaries is in principle exactly the same pquery C++ code. However, they are linked, each of them with their own respective client libraries, and so they might produce slightly different bugs. In general, you should only have to use one, but if you really want to go into the nitty-gritty, you could try all three. Also, for reproducing issues, sometimes it might be of interest just to play around with using a different binary, just to see if you can get an issue. And as you probably noticed by now, the pquery binary itself is just a symlink to pquery PS, so that's the one that we use. But you can just change that in pquery-run. So we have the pquery-run script, and we talked about that at some length, where you can actually start a pquery run after you set a few settings, and then it will start producing bugs for you. So that's fairly straightforward. So as of the date of this video, 5.6 is fully covered. 5.7 just needs a little bit of tweaking of the script. You can either do that yourself or simply wait until we've updated it to 5.7, simply because 5.7 initialization of the data directory is slightly different than 5.6. By the way, within the percona-qa framework, there's a very handy little script, and that one has been updated to 5.7. If you change directory into any base directory that you have. So the base directory is usually the one that has been MySQLD. So I'm talking about a tarball, right? You get a tarball from the MySQL website, you unpack it and you change into it. If you go percona-qa startup.sh, it will create a bunch of scripts. For instance, it will create start, client, stop, and a few other ones. And so if you unpack your tarball that you've downloaded from the MySQL or from the Percona website, and you change into that directory, you run a startup script, and then you go locally start, and then you wait 5 or 6 seconds for the server to start up. You go client CL, then it will bring up the MySQL client all the way nicely to the MySQL prompt for you, and you can play around with it. So that's part of the Percona QA framework too. Let me see if I can quickly show that to you. Yeah, why not? MySQL 5.7. Here it has those scripts already, so let me just remove start, stop, CL, test, and run Percona QA script startup. And then you want to add 0 to the end. You want to add 0 to the end. And the reason why is because we originally created the script in RGG times, and it would take a trial number and bring up that particular trial. But 0 simply means started up in this particular directory. So if you execute that, so again, just run startup.sh, and you want to specify a 0 behind it. And then you can see here it's got the start script. So if I execute start, and then just need to wait a little bit, there you go, and that brought up my server to the MySQL prompt. Okay, so just remember about that. And one small adjustment here is that you just want to run 0 behind it. Okay, so we saw that. So we haven't really used it within this particular video, but you know now that you can use mtr to SQL. I forget if it's underscore or not, to SQL.sh, and that will grab from a particular server. It will grab all the mtr test cases from the source code. Make sure that you got the source code for this, not the binary object form, and it will grab all the SQL and create your SQL file that then is used by pquery-run and by the pquery binary to execute against your MySQL D server. Okay, so in the next episode we'll go a little bit more into the utilities. So remember, pquery-run is a wrapper around the pquery binary. There are more tools like the pquery-run that go further into handling that particular output that we've been seeing. So if we have a quick look here into one of these directories, you can see another run here that I've previously worked at, and this particular one has already been filtered and cleaned up, and you can see there were individual trials. So in this case there were quite a number of trials happening, and these reducer files have been automatically created by one of the other utilities that we'll see about in the next video. So for the moment, I hope that you enjoyed the session. We saw about mtr to SQL, pquery-run, and my name is Roel. See you next time. Bye. God bless.